Okay, we're going to take the reciprocal of this quadratic function here. So the very first thing we're going to do is identify the x-intercepts and identify those with the vertical asymptotes. And I can see from this that this is where x is equal to -1, so there's one vertical asymptote, and over here this is going to be where x is equal to 3. So there's my second vertical asymptote. Okay, x-intercepts become vertical asymptotes. They are holes in the domain. So we might even say here that the domain is that x cannot equal -1 or +3. Okay, so once we've identified the vertical asymptotes, then I'm going to draw those lines across at y equals 1 and y equals -1. I draw those lines here so that it splits up the top half of the graph into two regions, the part above y equals 1, the part below y equals 1. The bottom half is split into two regions, the part above y equals -1, the part below y equals -1. Because in both halves of the graph, those regions are going to switch. Where my function crosses those lines are the invariant points. Okay, wherever the graph hits y equals 1, y equals -1, those are invariant points. And now, starting at this invariant point, I'm going to graph my function here. To the left of it, as I follow the graph to the left, the original function moves very quickly away from the x-axis, so my reciprocal has to quickly move towards the x-axis. To the right, and this is a little hard to see because it's a very tight interval here, but there's this very, very small interval where the function drops down. In that little interval, the reciprocal has to move up towards infinity. Okay? Now, I'm going to move on towards this middle section here in just a second, but over here is going to be the exact parallel of what we just saw here. From the invariant point to the right, it's going to drop quickly towards 0, and then it's going to shoot up to infinity right there. Now, inside, in between the two vertical asymptotes here, what I'm going to do here is notice that my vertex here is the point 1, -4. It is going to reciprocate up to the point, okay, 1, -1/4. Now watch what the function does. The original function starts at the x-axis here. It goes down through the invariant point, down through the vertex, up to the invariant point, up to the x-axis. This means that my reciprocal is going to start down here at -infinity, okay? Because that's what that vertical asymptote is doing. It's forcing this huge break here. So instead of dropping down, my reciprocal is going to shoot up. It's going to hit this invariant point. The original function continues to move down to this vertex. My reciprocal is going to move up to the reciprocal of that vertex. The original function then moves up to the invariant point. So my reciprocal is going to go drop down to the invariant point. And then the original moves up to 0, so my reciprocal is going to drop down to -infinity. The action is always opposite to what the original is doing here. And then finally, I'm going to state what my y-intercept is. The y-intercept of the original function is the point 0, -3. So the y-intercept of the original, now my scale is a little off there, you have to forgive that, but I'm just going to take the reciprocal of that. The y-intercept here would then have to be -1/3.